next concept, relation between electric field and potential for a 3-mark important question for the board exam or 2-mark question, very important question. For that we have taken the two equipotential surface A and B. The surface A which is having the potential will be V. The surface B which is having the potential will be V minus dV. Here we are taken by the two closely spaced equipotential surfaces A and B, in which the surface A is having the potential will be V and the surface B is having the potential will be V minus dV, where dV is the decreasing potential. Where dV is the decreasing potential is in the directions of the electric field. Is it clear? Therefore, we have considered the point P is on the surface B. Now we have to consider the point P is on the surface B, in which we are taken by the unit positive charge is known as 1 coulomb. The point P in which we are taken by the unit positive charge is known as 1 coulomb. That 1 coulomb of charge will be moving from the point is known as P to the surface A. Therefore, initially we are considered by the two equipotential surfaces A and B. The surface A is having the potential will be V and B is having the potential will be V minus dV, where dV is the decreasing potential. The equation itself gives the meaning V minus of dV. Equation ನಿಮಗೆ meaning ಅನ್ನು ಕೊಡ್ತದೆ. ಏಕೆ ಕೇಳಿದ್ರೆ ನಾವು ಹೇಗೆ ಬರೆದಿದ್ದೇವೆ ಕೇಳಿದ್ರೆ V minus of dV. That minus of dV represents the decreasing potential. That decreasing potential in this the direction of electric field. Now we are consider one point is on the surface B. That point is expressed by P, in which we are taken by the unit positive charge, that will be 1 coulomb. 1 coulomb of charge that will move from the point is known as, or from the surface is known as B to A. For that, when a unit positive charge is taken along this perpendicular distance, when the unit positive charge is taken along the particular distance, when a unit positive charge is taken along this perpendicular distance from the surface B to the surface C, against the work done or against the electric field, the work done is equal to, the reason is that the 1 coulomb of charge will be moving in the direction, 1 coulomb of charge ನಾನು ಎಲ್ಲಿಂದ ಮೂವ್ ಮಾಡ್ತಿದ್ದೇನೆ ಕೇಳಿದ್ರೆ that will move from the point is known as P. That point P is on the surface B. Point P ಎಲ್ಲಿದೆ ಕೇಳಿದ್ರೆ is on the surface B ಎಲ್ಲಿದೆ. Therefore the 1 positive charge is moving from the point is known as P, that is from the surface B to the surface C. That distance is called as a perpendicular distance. What about that distance is known as a perpendicular distance, that is expressed by dr, which means that the unit positive charge move from the surface B to A through a perpendicular distance is known as a dr. Therefore the direction is opposite to the direction of the electric field. Therefore there is a work done. Hadre 1 coulomb of charge ಅನ್ನುವಂಥದ್ದು ಏನಾಗ್ತಾ ಕೇಳಿದ್ರೆ ಸರ್ಫೇಸ್ ಬಿ ಇಂದ ಏನ ಕಡೆಗೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಆ ಡಿಸ್ಟೆನ್ಸ್ ಆಗಿದೆ ಕೇಳಿದ್ರೆ ಇಸ್ ಅ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡಿಸ್ಟೆನ್ಸ್ and the direction of that 1 coulomb charge is opposite to the direction of the electric field. Therefore there is a work done. Therefore that work done is written by dw is equal to E vector dot dr vector. Electric field force in terms of electric field we are taken. In general work done is equal to force into displacement. Force ಅನ್ನು ಹೇಗೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದಾನೆ ಕೇಳಿದ್ರೆ in terms of electric field. Therefore the change in work done dw is equal to E vector dot dr vector. Dot product is replaced by the function is called as a cos theta. Same equation ಅನ್ನು next step ಅಲ್ಲಿ ಬರೆಯುವಾಗ ಹೇಗೆ ಬರ್ತಿದ್ದೇನೆ ಕೇಳಿದ್ರೆ in terms of magnitude ಅಲ್ಲಿ ಬರ್ತಿದ್ದೇನೆ. Therefore dw is equal to, that will be E times of dr cos theta. That is equal to, where theta be the angle. It is the angle between the direction of the electric field as well as the direction of the flow of unit positive charge. In general, the unit positive charge that will move from the point is known as P to the surface A. That direction is opposite. Therefore, the angle between them theta is equal to 180 degree. Electric field na directions ಅನ್ನು ನೀವು ಹೀಗೆ ಬರೆದ್ರೆ ಇದರ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಏನಾಗ್ತದೆ ಕೇಳಿದ್ರೆ 1 coulomb of charge ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಹಾಗಾಗಿ angle between them theta is equal to 180. Cos 180 will be minus 1. Therefore, work done, change in work done, dw is equal to minus times of EDR be the equation number 1. Now this work done equals to, this work done is equal to the potential difference between the surface A and B. Here it is the work done that is taken in terms of an unit positive charge. Therefore this work done is equal to the potential difference between the surface A and B. Therefore in general the surface A is and the potential will be V. The surface B is having the potential will be V minus dV. Therefore that work done is equal to the potential difference between the surface A and B. Therefore the change in work done dW is equal to VA minus VB. VA is the potential is on the surface A. VB is the potential is on the surface B, that is equal to potential on the surface A will be V itself. Equation minus is as usual. Potential on the surface B will be V minus of dV. Therefore, minus of V gets cancelled out. Minus of minus will be plus. Therefore, the change in work done is equal to the change in potential that is expressed by the term is called as a dV. Therefore, dW is equal to dV is equation 2. Therefore, equating the equation number 1 and 2. Equation 1 will be dW is equal to E minus dr. Equation 2 will be dW is equal to dV. Therefore, equating the equation number 1 and 2, E minus of dr is because of equation number 1 is equal to dV. Therefore, electric field, in order to get the relation between electric field and potential, that is the reason why I rearrange the equation over here. Therefore, E minus of dr is equal to dV. Therefore, electric field E is equal to minus of dV divided by dr. Hence the proof, very important one, the negative sign. The negative sign indicates that the direction of the electric field E vector is in the direction of decreasing potential. The negative sign indicates that the direction of the electric field is in the direction of a decreasing potential. For a 1 mark question, in terms of a relation between electric field and potential, why there is a negative sign, or mention the expression or relation between electric field and potential. At the end we have to write the negative sign shows that the direction of the electric field E vector is in the direction of a decreasing potential. Hence the proof, very important 3 mark question or a 2 mark question. In 2 mark question you have to express the why it is negative. Very important, 2 mark ಅಲ್ಲಿ ನಾವು ಬರಿಬೇಕಾದಂತ ಟರ್ಮ್ ಏನು ಕೇಳಿದ್ರೆ, ಮೆನ್ಷನ್ ದ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆ್ಯಂಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನುವಂಥ ಕ್ವಶನ್ ಕೇಳಿದರೆ ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಅನ್ನು ನಾವು ಯಾಕೆ ಬರೆದಿದ್ದೇವೆ, ಅದಕ್ಕೆ ಮೀನಿಂಗ್ ಅನ್ನು ಬರೀಬೇಕು. ದ ನೆಗೆಟಿವ್ ಸೈನ್ ಇಂಡಿಕೇಟಿಂಗ್ ದಟ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಡಿಕ್ರೀಸಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ದ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್, potential energy of a system of 2 charges. The next concept, potential energy of a system of 2 charges in the absence of electric field. For that, initially we are taken by the 2 point. The 1 point will be A, the one more point will be B, in which the charge or the point A in which we are placed by the charge is known as Q1, which means that infinity in which we are bringing the charge from infinity to the point A. Thus, what about the potential over the surface or the potential on that point? The potential is equal to 0. Since at the point B in which there is no charge carrier or there is no electric field. Initially in a consideration we are taken by the 2 points. Initially now ಏನು ಮಾಡಿದ್ದೇವೆ ಕೇಳಿದರೆ 2 points ಅನ್ನು ತಗೊಂಡಿದ್ದೇವೆ. That point is expressed by A and B. The point A in which we are placed by the charge is known as Q1. There is no potential. ಒಂದು work done create ಆಗಿರಬಹುದು. Reason is that the charge Q1 is brought from the point infinity to A. A charge which is having the electrostatic force as well as the field. But in general, potential ಅಂತ ಸಿಗಬೇಕಾದ್ರೆ ಏನಾಗಬೇಕು ಕೇಳಿದ್ರೆ there is the presence of one more charge. But the point B is an empty point. Now, the charge Q2 is brought from the point infinity to the point B. Now we are bringing the charge from the point infinity to the point B. Therefore, now there is a potential on Q1. ಈಗ ಏನಾಯಿತು ಕೇಳಿದರೆ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಅನ್ನು ತಂದು ಪಾಯಿಂಟ್ ಬಿ ನ ಮೇಲೆ ಕೂರಿಸಿದ್ದೇನೆ, ಪಾಯಿಂಟ್ ಬಿ ನ ಮೇಲೆ ಇರಿಸಿದ್ದೇನೆ. ಹಾಗಾದರೆ ಏನಾಯಿತು ಕೇಳಿದರೆ there is a potential on Q1 is at a distance r from the charge is known as an Q2. In general, if you consider the single charge or the single point charge, the point charge which is having the electric field, thus it exerts an electrostatic force. ಒಂದು ಸಿಂಗಲ್ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಅಥವಾ ಐಸೋಲೇಟೆಡ್ ಚಾರ್ಜ್ ಅಂತ ತಗೊಂಡ್ರೆ ಆ ಚಾರ್ಜ್ ಏನು ಮಾಡ್ತದೆ ಕೇಳಿದರೆ ಫೀಲ್ಡ್ ಮತ್ತು ಫೋರ್ಸನ್ನು ಎಕ್ಸರ್ಟ್ ಮಾಡ್ತದೆ. ಇನ್ ಆರ್ಡರ್ ಟು ಗೆಟ್ ದ ಪೊಟೆನ್ಷಿಯಲ್ ವಿ ಮಸ್ಟ್ ಹ್ಯಾವಿಂಗ್ ದ ಒನ್ ಮೋರ್ ಚಾರ್ಜ್ ಇಸ್ ಕಾಲ್ಡ್ as an unit positive charge. That same charge is here we are taken as in terms of an Q2. The point B in which we are placed by the charge is known as an Q2. Because of Q2, the charge Q1 which attains a potential, therefore the electric potential due to the charge Q1 at a distance r is V1 is equal to 1 by 4 pi epsilon naught times of Q1 divided by R, according to the general equation. Now, Q2 is considered as a unit positive charge. Now that charge is moving towards the Q1. What it gains? It gains a potential energy. Since that external work done is because of a force, that external work done is opposite to the direction of the electric field. Therefore, then the potential energy of the charge Q2 is placed at a distance r from Q1. ಸೆಕೆಂಡ್ ಕನ್ಸಿಡರೇಷನ್ ಅನ್ನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಕೇಳಿದರೆ, ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆಗಿ ಅಸ್ಯೂಮ್ ಮಾಡ್ತಿರುವಂಥ ಚಾರ್ಜ್ ಯಾವುದು ಕೇಳಿದರೆ Q2. ಬೈ ಯೂಸಿಂಗ್ ದಟ್ ಚಾರ್ಜ್ ವಿ ಆರ್ ಮೂವಿಂಗ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಆರ್ ಇನ್ ದ ಅಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ಸ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೀಲ್ಡ್ ಆರ್ ದ ಫೋರ್ಸ್. ಪ್ಲಸ್ Q2 ಚಾರ್ಜನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಏನು ಮಾಡ್ತಿದೆ ಕೇಳಿದರೆ Q1 ಕಡೆಗೆ ಮೂವ್ ಆಗ್ತಾ ಇದ್ದೇನೆ. ದಟ್ ಈಸ್ ಅಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ದ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್. Therefore, the charge Q2 which gains an energy, that energy is called as a potential energy. Therefore, then the potential energy of the charge Q2 placed at a distance r from Q1 will be U is equal to V1 times of Q2. This relation is because of, in general we are done by potential V is equal to, potential V is equal to W divided by Q, work done divided by unit positive charge. Work done is taken in terms of an energy, that energy is called as a potential energy. Therefore, V is equal to U divided by Q. ಇಲ್ಲಿ ವರ್ಕ್ ಡನ್ ಅನ್ನು ಹೇಗೆ ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ದೇನೆ ಕೇಳಿದರೆ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಎನರ್ಜಿಯಲ್ಲಿ ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ದೇನೆ. ಹಾಗಾದರೆ ವರ್ಕ್ ಡನ್ ಅನ್ನು ಹೇಗೆ ಬರೆದಿದ್ದೇನೆ ಕೇಳಿದರೆ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಯು ಅಲ್ಲಿ ಬರೆದಿದ್ದೇನೆ. Therefore, V is taken as V is equal to U divided by Q. Therefore, what about U is equal to, by here in the equation, small v, potential V is equal to U by Q. Therefore, U is equal to V into Q. What about the potential? Potential will be V1 is because of the charge Q1. The charge will be Q2. The charge Q2 which gains energy. The charge Q2 which gains energy, that energy is called as a potential energy. Therefore, U is equal to V1 times of Q2. That relation is because of the, according to the definition. Therefore, U is equal to V1 times of Q2, that is equal to 1 by 4 pi epsilon naught Q1 is the expression for V1 times of Q2. Therefore, energy, potential energy of system of two charge in the absence of electric field is given by U is equal to V1 times of Q2, that is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R. Is it clear? One more 3-mark important question for the board exam. Arrive the expression for potential energy of system of two charges in the absence of, ಇಲ್ಲಿ ನಾನು ಬರಲಿಲ್ಲ ಹೆಡಿಂಗ್ ಬರೆಯುವಾಗ, in the absence of electric field. Yes, potential energy of system of three charges. Consider 3 points, point A, point B and the point C. Initial potential is equal to 0. All the 3 points which is having the initial potential is equal to 0. Since the reason is that there is no charge carrier or isolated point charge, then there is no electric field also. Now, the charge Q1 is brought from the point infinity to the point A. There is an external work done, but the charge Q1, it must possess the electric field as well as the electrostatic force. But the potential is equal to 0, that work done is also considered as 0. Now, the charge Q2 is similar to the first derivation. The charge Q2 is brought from the point infinity to the point B. Now, there is a potential on Q1 is due to Q2 is at a distance R1, and that potential is written by, is at a distance R1, and that potential in terms of a potential energy is written by U1 is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R1. As I already said, the equation according to the potential energy of system of two charges, this equation. The reason is that initial ನಾವು ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ದೇವೆ ಕೇಳಿದರೆ, ಇನ್ಫಿನಿಟಿಯಿಂದ ಪಾಯಿಂಟ್ ಎಗೆ ಇನಿಷಿಯಲಿ ಒಂದು ಚಾರ್ಜ್ ತಂದಿಟ್ಟಿದ್ದೇವೆ, ಪಾಯಿಂಟ್ ಎ ಅಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ತಂದಿಟ್ಟಿದ್ದೇವೆ, that will be Q1. External work done is there, but that energy is equal, that work done is equal to considered to be 0 since there is no potential. The one more charge that is brought from the point S known as infinity to the point B. Now the charge Q1 which has the potential is due to Q2 is at a distance R1. Because of that potential, the charge Q2 which gains an energy, that energy is called as a potential energy. According to the first derivation, we are having the idea, potential energy of system of two charges, that is given by U1 is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R1. Now, these two charges, the charge Q1 and Q2, which produces electric field all around, before introducing the charge over the point C, the point C which is having the potential is because of Q1 and Q2. Because of these two charges, the charge Q1 and Q2 which produces electric field all around, ಈ ಎರಡು ಚಾರ್ಜ್ಗಳು ಏನು ಮಾಡ್ತದೆ ಕೇಳಿದರೆ, ಇದರ ಸುತ್ತ ಏನು ಮಾಡ್ತದೆ ಕೇಳಿದರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನು ಜನರೇಟ್ ಮಾಡ್ತದೆ. ಬಿಫೋರ್ ಇಂಟ್ರೊಡ್ಯೂಸಿಂಗ್ ದ ಚಾರ್ಜ್ ಈಸ್ ಅಟ್ ದ ಪಾಯಿಂಟ್ ಸಿ, ಪಾಯಿಂಟ್ ಸಿಗೆ ಚಾರ್ಜ್ ಅನ್ನು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡುವ ಮೊದಲು ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ, ವಿಚ್ ಗೇನ್ಸ್ ಎನ್ ಎ ಪೊಟೆನ್ಷಿಯಲ್, ದಟ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಎಸ್ ಎನ್ ಎ ವಿ, ದಟ್ ವಿ ಇಸ್ ಬಿಕಾಸ್ ಆಫ್ ದ ಚಾರ್ಜ್ Q1, that V is because of the charge Q1 is at a distance R3. The potential at the point C is due to the charge Q2 is at a distance R2. Is it clear? The charge Q1 and Q2 produces electric field all around. Before introducing the charge at the point C itself, the charge C gains a potential that is expressed by V, that is at a distance from Q1, is at a distance R3 from Q1 and R2 from Q2. Based on that, we are done by the equation V is equal to the charge Q1 and Q2 produces electric field all around. The electric potential at a point C, which is at a distance R3 from Q1 and R2 from Q2 is V is equal to 1 by 4 pi epsilon naught Q1 divided by R3 plus 1 by 4 pi epsilon naught Q2 divided by R2 according to the general equations of potential. Now, the work done in bringing the charge Q3 is from the point infinity to C. Before introducing the charge, the point C itself is having the potential. Charge ಅನ್ನು ಇಡುವ ಮೊದಲು ಏನಾಗಿದೆ ಕೇಳಿದರೆ ಪಾಯಿಂಟ್ ಸಿ ಎಲ್ ಏನಿದೆ ಕೇಳಿದರೆ ನೋಡಿ, ಚಾರ್ಜ್ Q3 ಅನ್ನು ಪ್ಲೇಸ್ ಮಾಡುವ ಮೊದಲೇ ಪಾಯಿಂಟ್ ಸಿ ಎಲ್ ಏನಿದೆ ಕೇಳಿದರೆ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ Q3. Sorry, it is having the potential will be V. Now we are placing the charge will be Q3. What happens? The point charge Q3 gains in a potential energy is because of the potential. I repeat, puna point and repeat ಮಾಡ್ತಾ ಇದ್ದೇನೆ. Before introducing the charge that is known as Q3 is at the point C. The point C is having the potential. Therefore, the work done in bringing the charge Q3 from infinity to C is, when the charge Q3 is brought from the point infinity to C, the charge Q3 gains a potential energy, not a potential, it gains a potential energy. That potential energy is because of a potential. And that potential is because of these two charge carriers. Therefore, that is written by work done in bringing charge Q3 from infinity to C is given by U2 is equal to V times of Q3. Potential energy of the charge Q3 is expressed by U2 is because of the potential is known as V. Therefore, the value of V is equal to 1 by 4 pi epsilon naught Q1 divided by R3 plus 1 by 4 pi epsilon naught Q2 divided by R2. That I substituted here. U2 is equal to 1 by 4 pi epsilon naught Q1 divided by R3 plus 1 by 4 pi epsilon naught Q2 by R2 times of Q3. That Q3 that are multiplied over here. Therefore, U2 is equal to 1 by 4 pi epsilon naught Q1 times of Q3 divided by R3 plus 1 by 4 pi epsilon naught Q2 Q3 divided by R2. Therefore, the total energy U is equal to U1 plus U2. Therefore, U is equal to, what is the value of U1? 1 by 4 pi epsilon naught Q1 Q2 divided by R1 plus 1 by 4 pi epsilon naught Q2 Q3 divided by R3 is because of U2. Then 1 by plus 1 by 4 pi epsilon naught Q2 Q3 divided by R2. Hence the proof. Potential energy of system of three charges in the absence of electric field is